Hi there, so I was asked to help solve for this problem here. It's problem number 33, one of the first ones in your homework. And the question is actually just find the remaining trigonometric functions of theta. So find sine, cosine, tangent, secant, cosine, cotangent. In our problem here, they gave us tangent to start. And for me to find sine, cosine, tangent, secant, cosine, cotangent, I need to have the triangle drawn out. Okay. Now they gave us some hints about where the triangle should be and what quadrant it should be. First, they told us the tangent is going to be 2, also that the sine is positive and the cosine is positive. So far, these are all positive. Tangent is 2, that's positive, right? And sine is greater than 0, cosine greater than 0. That means these are all in quadrant 1. So if I would actually start off here, if I would start off with this bit of information on my left, I always draw my cross. We're given tangent is positive, so that's in quadrants 1 and in quadrants 3. We're given tangent theta is equal to 2 or 2 over 1. That's my opposite and my adjacent side to this triangle. Now, before I start filling in the sides and wasting a little bit of time here, they told me that the triangle also has to be sine is positive and cosine is positive. If you remember what quadrant is what positive or negative, we use our easy way of all students take calculus. So everyone is positive in quadrant 1. Sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. Tangent here is positive in quadrants 1 and 3. That's how I knew to draw the triangles there. But only one of these quadrants is sine and cosine also positive, and it's positive in quadrant 1. Sine and cosine would have been negative, so you have negative and negative in quadrant 3. So we actually don't even need this triangle here to save time. All right, let's go ahead and fill in the sides that we do know. We know the opposite is 2 and the adjacent is 1. And this normally would remind us of a 36 and 90 triangle, but it's not. Let's look at a 36 and 90 triangle on the side. 1, 2, square root of 3, where 2 is the hypotenuse. See, the 2 is the hypotenuse side. So that's not going to be a Pythagorean theorem. So let's go ahead and find the third side using Pythagorean theorem. 1 squared plus 2 squared is equal to my hypotenuse, c squared. That's going to be 1 plus 4 equals to c squared. C is equal to the square root of 5. So now I know that my hypotenuse here is going to be square root of 5. And we have all three sides, so we can now declare our sine, cosine, tangent. Here we go. Sine of theta, whatever the theta was, is going to be opposite 2 over hypotenuse square root of 5, which can be rewritten with the square root on top, 2 square root of 5 over 5. Cosine of theta is adjacent over hypotenuse, can be written square root of 5 over 5. Tangent is already done, and we said that was going to be opposite over adjacent, which is just 2, which is what they gave us. Perfect. Cosecant, which is just a reciprocal identity, is hypotenuse, so it is hypotenuse over opposite. We don't need to change that one because the square root is on top. Secant theta is square root of 5 over 1, or just square root of 5. And cotangent of theta is 1 over 2. So they wanted the 5. Here are the 5. So the main goal is to first be able to draw a triangle. Once we have our triangle, we know all the sides, so we can complete the trig ratios.